It's not unusual to be known by anyone. Hey, ROS developers, are you ready there for another ROS live class? Yes, I'm excited. Sorry, I'm here putting the sound of the other computer down so I cannot see myself. I cannot hear myself, sorry. So how are you doing, guys? Are you working okay with the past live classes? Are you happy with them? Then in this live class, this is another exciting live class where we are going to touch it's a kind of a basic stuff about ROS, but many people have a struggle with that. And this is about how to create the URDF structure of your robot. So, but I suppose that you know how to do it. Okay, so, but in this live class, what we are going to do is to check if what we are building after every step of building the URDF model of our robot, check if we are doing properly, if we are putting all the pieces of our model in the proper location with the proper orientation and able to move in the directions that we would like to. So that's what we are going to deal with today. Okay, so let me check on the chat who is the people that is arriving here. As always, we have Gianfranco. That many of the days you are here. Hello, Gianfranco. Also, the first one to arrive was Code Hunter. Hello, Code Hunter, and also was chatting with the concept guys there on the chat. Great, Marcus. Oh, hello, Marcus. How you doing? Then which one? Denisa, Andrea, and then another name in Chinese, but it's not the previous one that I was always doing mistakes. So hello, Chinese. I think that this one is a girl, but I cannot see clearly the picture. So tell me your name there I would say in English characters, so I can provide that. Then there is Orion that just arrives. Hello, Orion. And Der Kaput, that he's always here. And we are trying to do with Der Kaput some online meeting, but we never achieved to do that for some reason. I don't know. Sometimes he's failing and sometimes it's me. Yeah, so probably someday we'll do it. Then Benito, yeah, very nice name, Benito. Yes, so nice to meet you. I can see the joke in your name. And then Riel, hello, and more people coming there. Okay, guys, let's start because we have some work to do. Then let's continue. What are we going to do? So we are going to use the ROS Development Studio to follow the class of today. And why is that? Because on the ROS Development Studio, you can practice with ROS at the same time as I am explaining. So you don't need to install anything on your computer. You can use Linux, Windows, or Mac, and then you are set up already. If you are watching this video, then you are set up. Great. Then what I'm going to do is to share with you the notebook that contains the instructions and some code for the class of today. So I'm going to share that with you. How I'm going to do it? By sharing the link of the ROSjet. And then I'm going to put the link of the ROSjet of today on the chat there, and I will, so you can click on this link and you will get a copy of my ROSjet, the one I have prepared. But actually, I have to say that this ROSjet was not prepared by me. It was prepared by Christian Chavez, who is one of the interns of here in the construct under my supervision. So he is the actual creator of the notebook today. So I'm going to share this with you, and then you can open it and start practicing with me. That is it. That is it. So let's see how to do all that. Okay, I'm going to share my screen with you so you can see the steps. Yes? So let's go. Let's go, and let me first share my screen so you can see what I'm doing. In case that you would like to replicate this with in the future with your own ROSjet, remember that you can use the ROS Development Studio for free, and you don't need to pay anything. And then you can create your own ROSjet and share with your students, with your friends, and whatever. Then let me see. So this is the ROSjet of today, and I'm going to share with all of you the current link for this project. Okay, so this is my zone of the project, and I have so many here, many related to the live classes as always, but the one that related to today is this one. Okay, so I'm going to press here share, and then I'm going to copy this link here. Okay, so I copy it, and now I'm going to share this. I'm going to paste this right now into the chat here. So let me go to the chat. So wait a second, because I have a problem here going to the chat. Come on, go to the chat. Okay, I have a problem accessing the chat here. Okay, I'm getting there. Yeah, almost there. Yeah, so there it is. So I'm pasting here the project. Then what do you have to do? You have to click on the link that I have posted on the chat, and then by clicking there, you are going to get a copy of my project automatically. In case that you don't have an account here on the ROS Development Studio, then it will ask you to create a free account, okay? And then afterwards, when you create a free account, by clicking on the link, everything is going to be guided. So don't worry, very easy. At the end, you are going to end with this project here in your zone of your projects. You see here is your projects. Then once you have this, then click on the More button. This window will open, and then press on the Open Project button. Then by pressing this, then after a few seconds, then it's going to open the project with the current status. And I don't understand why this is happening again, but we have been working the last week on correcting this amount of time, and for some reason it's not working yet. Yeah, so something strange. I mean, it's working, but the problem is that it's taking too long time here. So I should not be there waiting for so long. But anyway, so in the meantime, let me go to the to check the chat and see what is people saying, because too many things here. And let me see, where is the chat? Where is the chat? Let me disconnect here oh, here it is. Okay, so here again, so I'm checking that everything is correct here, but let me go to the chat. So to the chat, we have Orion that is there. I already said. Riel, Joseph, hello, how you doing, Riel? Shalom Liu. Oh, but then, so Shalom Liu, so it is you. So, but okay, so I don't understand why I always confuse with your picture and with your Chinese character. So I thought that I was able to recognize this. I can understand that there is one of the ideograms, one of the characters is the character for small, I think, is the one in the middle. And then, so I got confused again. Okay, so then we have JT that is there, Jim Mahoney. He is coming from ROS Agriculture. Okay, nice to have you here. A big hug to all the people from the ROS Agriculture group. And Azet from Aachen in Germany, and Rakmit, Riel, Joseph from the Philippines, and what else? More people there. And I have already my project open here, so we can continue. Let me share with you again my screen. So let me share. And then once you have opened the project of the link that I have provided to you, you should get a screen like this, restore workspace. You can ask no. Then by asking no, the notebook is going to open automatically. And this is the notebook that we have prepared, Christian has prepared, and then it's here with all the material that we are going to cover today, okay? So in case that you lose this window for whatever the reason, or because you close it or you click somewhere or whatever, then remember that you can open very easily by going to Tools and pressing Jupyter Notebook. Then this is going to show you all the Jupyter notebooks that have been added to this ROS, visualizing using URDF, and then press on the file that you want. In this case, there is only one notebook, the one of the class, so press there, and then it is going to open again. Okay, and then Code Hunter is saying that the ROS has been opened, and JT from the US, Suresh Kumar, hello, and Andrew from Italy. Very good. More people arriving from Mexico. Awesome content. Yes, that's it. Daniel Alfonso. Yes. Let's go. Let's start practicing. So what is this class about? As I mentioned at the beginning, it's about creating the URDF of a robot. You know what is the URDF? Yes. The URDF is the file in ROS that is describing the structure of your robot. Then this is very important because many of the ROS programs need to know the structure of your robot. That is why you need to create a URDF of any robot that you are going to have if you want to use it with ROS. Okay, then of course, as basic previous knowledge, you need to know basic ROS in order to understand what I'm going to speak here. And in case that you don't have this knowledge, I have included here a link to an online course that we have created about that, about basic ROS knowledge. And also, I am assuming that you understand how to create a URDF of a robot, even if it is not a very difficult robot, a simple robot, but you have to understand that. If that is not your case, then here there is another course about how to create. If you click on this link, you are going to get into this course that is going to show you step by step how to create different robots with different structures, etc. Well, you'll have a look at that afterwards. And then what are we going to learn here? First, how to create a physical robot link by link of that fish here that we have here. So you are going to learn all the links and the joins that connect the different links in the URDF. Also, we are going to learn how to use the RViz, so you can visualize how the model, the URDF that you are building, the URDF file, how is it actually looking? Because the URDF is a lot, as you are going to see, and you probably know, it's going to be a lot of numbers and letters there, and it's very easy to do a mistake, and then afterwards find the error. Sometimes it's difficult. So we are going to use the RViz tool in order to visualize how are we doing? How are we doing? So I have added this link and this join for the robot, how I am doing it. Then finally, we are going to use the joint state publisher in order to check if the robot can move. It's not only the structure, but if this structure can move more or less in the parameters that we would like to, and we have described in the URDF. Okay, so that's it. Just remember that this is a ROS. What you are watching here is a ROS that you can create your own ROS with your own materials. And here I have put it some other links if you want to learn how to create your ROS. For example, with additional ROS code for simulation, you can include everything here, data sets, and then share with anybody and reproduce. So you have the links there. Have a look whenever you have some time. Then what is the robot that we are going to build is this one, this fish here. And then it's composed by several parts. So one blue, then two red, then the gray areas here that are some parts that the robot uses for direction and movement. And also, of course, this, I don't know how to say that in English, so sorry for that, but you understand me. And then these pink areas, there is one on this side and another one on the other side. Okay, so let's go. You have to practice with me, okay? So you have to follow my steps and you can do it. In case that you cannot do it, you are stuck or you have any problem, please put your question on the chat. I'm keeping an eye on the chat here on my left-hand side, and then I will try to answer your question so you don't get stuck. Let's go. Then first thing, we have to create the package, the ROS package that is going to contain the URDF of the robot. How do we do that? Well, let's create a package in the simulations workspace. For that, we need a shell. Yes, let's go to Tools here and open a shell. So that's a typical Linux shell. You know, for ROS, we are using Linux. Even if there is a Windows version of ROS, but still very early state, so we are waiting for that. And I can see here that I have some problem here in the 5G. So I'm going to try to switch the Wi-Fi because it's getting a lot of time. So let me switch it very quickly, very quickly. So I am here, I'm back. And of course, with the fastest 5G connection, here it is. So let's go to the simulation workspace. Then to create a Catkin, to create a package, the ROS package. So this is on simulation workspace. And remember that we have to create our packages on the source. Okay, so some problem here, some disconnection. I don't know if it is related because I changed the Wi-Fi line. Yes, let's go. Okay, so let's do it again. Simulation workspace / source. There it is. Let's create a package. I have included here the command. And yes, so it's just the Catkin create package that you already know. We are going to call our package narrow description. And we have included ROSPy here as a dependency, even if it is not necessary in this case, because we are not going to create any code, but just for the future, in case. So creating the package, and there it is, that has been created. So now we have to create a URDF file inside that package. And for that, we are going to use the IDE. This is the integrated IDE inside the ROS. So for that, you need to go to Tools, and click on IDE. Yes, that simple, that simple. And now we are going to, let me put it here in the middle. It's clearer for me. And I hope that you can see also. Where is my package? The one that I have created. It is here inside the simulations workspace. Remember, inside the source directory. So here it should be the narrow description. You also have to have this package there created now. So let me open it, and I see that there are some files inside and the source directory, but I don't need those now. What I need is to have one URDF directory. So for that, click on this directory and right click and then say new folder and create a new folder called URDF in non-capital letters, okay? So non-capital letters. Then inside that URDF, you are going to create here in the URDF, you are going to do right click again and then new file. Instead of folder, now new file. And we are going to create our URDF file there. And the URDF file is called narrow.urdf. I put those names that I am indicating because some code you have to copy and paste some code, and if you change the names, then this copy paste will not work. So we have to copy paste because we don't have all the time of the world. Don't worry. So after you have mastered this class, you can change your names and create your own names for your own files. Don't worry about that. Okay, so we have this narrow URDF. It's empty at present, and now let's create another folder that is going to contain the meshes of the robot. Remember that a robot, when we create a URDF, we have to create two things. One is the physical shape that the simulator is going to take into account in order to check for collisions. This is the collision part. But then that usually, that part, the collision part, we usually simplify into very simple shapes in order to allow the simulation to run faster. It's a matter of running faster. But then we can add to that simulation, to those shapes, something on top that is only visual. That this is only the visual part of every one of the parts of the URDF. That's what we call the visual part, and it's created by using meshes. So you should create those meshes by yourself for your robot. And that's a lot of work usually. If you want to reproduce your robot, then you will have to create those meshes with those shapes. So you have to know how to do this in 3D, in a program, for example, like 3D Studio or Blender. But in this case, we are providing to you the meshes for that fish robot here. And the meshes are contained here in this file that you can see here, meshes.tar. So we are going to uncompress this inside our package, because we need it in the proper structure in our package. Then for that, first we have to create a folder called meshes inside our package. So go to the narrow description, select it, and then right click, new folder, and call it meshes, as it's indicated on the notebook. Okay. So here it is, the meshes, the source that was automatically created by the catkin create package command, and then the URDF that we have created and that we have inside the narrow URDF. Okay, so now let's put inside those meshes these meshes directory, the actual meshes files. Okay, and for that I have included this command here that is going to uncompress that automatically. So if you don't understand this command, then you need to learn some Linux for robotics, and because this is very typical Linux command and we are using it a lot. So by the way, next week we are going to do a live class about Linux for robotics. So maybe that's a good point. So if you don't understand, just copy this and paste. So you can safely copy this and then paste it here on the terminal, on the shell that we opened previously. You can put it there. And now I have the meshes, all those files, they have been uncompressed. If you go to the meshes directory now, you should see those files there. Okay, they are DAE, that's collada format. That's collada format. Okay, so we have that ready, our meshes. So whenever we visualize our URDF, it's going to show those meshes. So it's going to show a proper shape, a proper wave. Okay, let's start constructing now our URDF that we have here using those meshes. So the first tag that you have to use is the robot that you have here. So copy this robot tag from the notebook, robot name narrow, then copy it here. So this is the basic tag. And then let's do one thing. In order to make it easier to understand, go here down on the blue area of the IDE where it says plain text. Click on there and then select on the list that appears, select at the bottom, it says XML. So if you click there, then you can see that this is showing in colors. It's a lot easier to understand and to visualize also the code. Okay, so that's not important. If you cannot do that or you don't want to, don't worry. This is just for easiness. Okay, great. So we have here these robot tags, and then we are going to include all the robot links and joins for our fish robot between those tags. Okay, so everything has to be between those tags. So let's make some space there. And let's copy the first link that is here. Okay, so remember that we have copied first the robot tag, and then now let's copy this link tag. You can copy and paste there. Then one thing is that I recommend that you use indentation. So let me select everything and then press tab in order to increase the indentation. So now I have clearer vision. The thing that we have here is the first link. It's called the base link. And as you can see here, as I indicated, there is the visual thing. Since we are not going to use the physical part, we are not going to simulate. Today, we are not simulating, just creating the URDF. Okay, so that's different. For simulation, we also need the URDF also, but with additional tags. Okay, so because today we only want to visualize the URDF model, we are putting here only the visual tag. And as you can see in this visual tag here, you can see that we are using our meshes, one of the meshes that we have uncompressed. Okay, very good. So here on the notebook, you can see that the final result that you should get. This is for step, okay, checking. Okay, so let's visualize this. That's the current state. I want to visualize. I want to see how it looks for the first link. Let's have a look. Then first, remember to save by pressing here in File, Save, or also Control S, okay, to save your result. Yes, that's it. Then let's go to launch this so we can visualize into RViz. For this, we need to create two launch files. The first launch file is going to be the launch file that will launch the whole robot in case that we would like to use it in ROS. So in case that you would like to use ROS, then you need to launch, you need to create a launch file similar to this one here. Similar. Some differences, but okay, so I'm not going to go into details here because it depends on the situation, on what you want to use this file for inside ROS. Okay, so for now, this is a kind of a general one. And then let's do it. Let's create it. And we need to create another directory called launch inside the package. Okay, we need another directory here. So you know the procedure. Go to narrow description, then right click, new folder, and put the name, it's launch. Then inside that, then you know it. Go to launch, right click, new file. And the first file is going to be called narrow underscore complete.launch. Okay, so there it is, and it is open. And we are going to take the code for that file here. It is here. You can check on the notebook. So you can safely copy all that, copy and then paste on this narrow complete launch file. And then remember to save it, okay? Control S or File, Save. That's it. So what does this file do? It is supposed that you should understand what it does. And then in case that doesn't, I'm going to explain it very quickly. So the first thing that it does is to load the URDF file into the param server. So the URDF file that we have constructed up to now, then we are going to load it into the param server of ROS. Then we are going to launch the joint state publisher. That is a program that allows us to publish values into the joints of the robot. And then the robot state publisher, that is another ROS program that allows us to publish the TF, the transforms of the robot. If you don't understand that, then you need to study a little bit more of basic ROS. And I have put some links around the notebook for that. Don't worry, and don't worry, because you can continue in this live class without a problem. So you're going to understand. So this is a launch file to launch everything on the robot. Well, everything that is required for launching the robot. And in case that you don't understand what are the joint state publisher or the robot state publisher, I did a previous live class here. You have the link and you can watch it later. It's another video like this one. And I explain clearly what is the difference between those, how to use it, and what is the purpose, etc. So it's quite simple. Okay, so now this is the launch file that loads everything required for the robot in ROS. But now what we are going to do is to create another launch file that will help us to visualize that code into RViz. So we need to create another launch file here in the package, in the launch directory. Oops, sorry. Here, yeah. So go to the launch, new file, right click, new file, and then the new file is going to be called, I don't remember, but let me put it because otherwise, if I don't use the same names, we can get problems then afterwards. So URDF underscore visualize dot launch. Okay, there it is, and then you can copy the code that is here. So copy paste from the notebook. And you can see here in this case, what this launch file is doing is actually yeah, so it's this is the one that the file that we are going to launch in order to see on RViz. And what it's doing is basically calling first the previous file that we have done it. So it's going to call all the code here, the one is going to load the robot URDF into the param server, is going to launch the joint state, is going to launch the robot state publisher. That's what is going to be this part here. And then afterwards, it's going to show the RViz. So it's going to start the RViz with a very specific configuration that you can see here. Okay, so this specific configuration is a configuration file that I have included here beneath. You can see here, it is there. Okay, you don't need to open. And it's a config file that will allow us to see it's already configured with a proper frame and with the proper windows. That's very, very simple config file, but just to move faster. Okay, remember to save, because if there is a ball here, it's a dot here, a white dot here, then it means that you have changes to the file that you haven't saved. So remember to save it, Control S or File Save. Right, so we have everything in place to start launching it. So how do we do? Well, we launch this last file in the terminal. The last file that we have created, we have to launch it. For that, go to the terminal and then do the ROS launch command. The ROS launch command is ROS launch, the name of the package. What is our package name? narrow_description. Narrow description. And then the name of the file that we want to launch, that is the URDF one, URDF visualize. So launch it, and everything is being started, it looks like, correctly. We can see the joint state, the robot state, and the RViz. So it looks correct. Okay, where is my screen? Where is my screen? I want to see my screen. Okay, so how do we do that? First, by going to the graphical tools. Because the RViz is opening a new window, then we need to use a specific tool for using this on the web. And that tool is inside here, the tools and graphical tools. If you open it, a new window will appear here in the desktop. And then we should see the RViz here. Some problems with the communication. Let's see. Let's see, connected. Let me do a re-enter. What is something here strange? Let me see. Let me take some coffee. Usually that solves everything. If I take some coffee. Okay, too many options, too many sessions. Let me do cancel and click enter. Waiting for response. Waiting, that is taking too much. This is very unusual. Let me move it forward. Let me close it and launch it again. Okay, that's a typical mechanism for these situations. Okay, so I cannot see here the graphical tools is showing some error, so it's not connecting. It should connect, but it is not. So let me see. No, still not. Let me refresh this. There is an icon here for refreshing also, but usually that should be the same process as when I launch it. So the results should be the same. That's very strange. Okay, so let me come here. Let me know if you are having the same problem, because in theory that should be very, very simple. So let me see if I can graphical tool, launch it again. The graphical tools, and it's not responding. Okay, so if it is not working, let me launch, for example, another simulation. Yeah, people, it's reporting, Riel is reporting, for example, that he has already opened it. Great. Good. Yeah, that's the normal way. So I don't understand why it's not opening for me right now. And let me check the processes here. So I'm going to do this here. Let me check. Then there should be one here. And yeah, it looks like this process is not running. Let me see. I'm checking here about the process that should provide us with the system, with the proper connection to the tools, to the desktop. That actually is a desktop server, but I cannot see here. So let me. I don't remember if it was. Yeah, okay, here, there it is. So the process is there. Let me do service restart of what the. Okay, so it's not recognized. And then, okay, so I don't understand that. And then probably I will have to relaunch. If it doesn't connect now, then I will have to relaunch my screen. So my ROS, basically. So let me do one thing. If it is not doing this, so let me check that everything is running, is safe, everything here. So I'm going to save my ROS, the current state, so I can start from there again. Okay, and then let me go back and relaunch it again. Oh, that's a copy, yeah. So let me go here to my ROS. And then Salvatore is reporting that he's seen only the blue head pointing downwards. That is correct, because it's the only link that we have added. So that is no problem. So let me check, let me check open another ROS, a different one, and see if it is working. If we can get this and still connecting to the remote services. And then there is a question by Riel that says, Riel Joseph says, what does this command do? It says cat the arc URDF mobile robot file. Okay. Yeah, okay, yeah, I can see it. So very basic. So arc URDF robot file, and then the $sign means that you had to replace all that with the parameter that has to be provided to that ROS file, to that launch file. And so it means that it's very difficult without having the code here in front of me, okay? So then the command is, the URDF robot file is a parameter, is an argument that you have to provide to the launch file that contains this line. You have to provide a robot file name that contains the URDF. Then cat $, this argument means, please put the content of this file into the command. So you know what is a cat command, do you? From Linux? Okay, so let me check. I have opened here my ROSjet, a new ROSjet, and then, yeah, it's showing here the desktop as usual, yeah. So that's a desktop, it's an empty desktop because I haven't launched anything. It's from another one. So let me go back and check again, launch again the current from this class. Okay, so here it is. And yeah, so I was on some point here launching the RViz. So I had to launch it again, ROS launch. It was narrow description, URDF. Then I launch it here, and then I'm going to the graphical tools. We should see here yeah, that's correct. So that's how it should be. So I don't know, maybe we have a bug in some place here in the ROS Development Studio. We have to analyze later. So basically we have this, and that's what Salvatore was indicating, that we have here the first part of the fish. Yes, it's pointing downwards, yeah, because the reference frame, that doesn't matter. So you can, that's not important. So, but we basically have here the first piece, and it looks correct. Then let me see one thing that is, yeah, is everything correct? Okay, great. Then let's continue building this model. Okay, let me open the IDE again. Let me open it and make it bigger. So I have to open all my files that I was developing. So narrow description, then URDF, narrow URDF. Okay, so that's the current state of our model. Let's add the other pieces. So what you would do once you have the first one correctly, then you do is to add another piece. So more pieces means more links and the joins that are connecting different links. So let's add another link here, the one that we have here. It's the second link, and also it contains a join. So you remember, you have to copy this and put it after the closing link of the previous link. Okay, so paste it there, copy and paste it there. Yeah, that's very strange. Oh, yeah, because I deleted. Okay, there it is. So now what do we have? Let me do one thing. Let me maximize this here so you can see better. And here we have added a second link. And then we also have indicated the joint that is going to connect both links. So it's going to connect this link with this link by means of a joint. Oh, Riel, yeah, sorry, almost forgot. You mentioned, I hope that you understood the question, but let me see, where did you get that? Okay, so it's here. Yeah, related to your question is, what does it mean, this command here? So basically, that what it means is that it's going to do a cat. A cat is get all the content of a text file. Actually, it should be a text file, okay? So get all the content of a text file. Which text file? The one that we can get by this command here. And what does it mean, this command? It means, because it's $R, it means you are going to get the name of the file for this cat command from the argument that is provided to this launch file. Is an argument that is called URDF robot file. Okay, so somebody who calls this launch file should provide this argument with the name of the file. And who is calling this? So the URDF visualize. And then, as you can see here in the URDF visualize, we are calling it here, and the arg name URDF robot file is this one. Okay, so it's the narrow URDF file that we are building here. So that's it, just to conclude with your explanation, Riel. Okay, so I have added the second link and the join that connects both. So remember to save, because it's a dot there. Save it, and we are going to do the same procedure. So open again the terminal. Here you must close this one. You must close here and relaunch. So Control-C the previous one, and you must relaunch in order to see the results. And then you can see that here now we have two pieces, because we have included another link and the join that connects both. Okay? Yes. Okay, so far so good. We have something more to add, but given the time, let's go straight to the end. So because we are copy pasting, so we are in a safe position. Okay, so we are in a safe position. Then the notebook continues by explaining how to add all the other links. So here a third link, and the join that connects, and then the other links here. And let me go to this point here. let me go to this point. So before here, because we have included a small error, so you can understand why is the reason of doing this procedure. Why? So we have included this small error. So what we are going to do, stay with me. I hope that I'm not losing you here, but it's just before this image here that you can see here, we have the code that we should have for this status of the robot. Okay, so let's select all the codes here in this cell just before. So Control C, this code here, and go to the URDF and replace everything that is there by that code. So by doing that, what means? It means that you should have the results of this visualization. Okay, let's test it. So let's go to the terminal, close the current program, Control C to close it, and then launch it again. And here we should see the RViz with, oh, sorry, I did it myself, the error, not saving here. You see, I didn't save. So remember to save. And yeah, so go back to this terminal, close it, and launch it again. There it is. Now, yeah, you can see here that the model is not correct. Why is that? It's because we have added the latest, here you can see the latest link, but there is some error in there. So why is that? You see that it doesn't show like it should be. As here, if I show you the model, the actual model that we would like to have, you see that this part here is looking the other way around. This is very common to happen when you are developing the URDF of a robot. That is why you need to have this tool as a RViz for that. So what is the problem here? Well, the problem is very simple. That's a fake error. We have introduced it. Christian has put it there in order to show you an error, a possible error that could happen. And the error is that here in this link, there is a 3.14 value on the these are the angles, the orientations of the piece. So let's have a look here on the code. On the narrow caudal fin link here, we have here the RPY values, and here we have the 3.14. We have to remove it and substitute by a 0. So that's the correct one. Okay, so now what we would do is to go back to here and then close. That's the current procedure, okay, the usual procedure. So you launch it again. Oh, let me see if I have saved. Yes, I have saved. Okay, so let's go back here, launch it again, go to the RViz window, and now is correct position. Okay, so yeah, so that's basically the reason why we are doing this. I mean, this robot is very simple. It's just an example. But imagine a humanoid robot building that, or an arm, a mobile manipulator also. It's already there. Okay, so let's go until the end where we have the full structure. You can keep, as you can see, we have included step by step for all the parts of the robot, but getting late. So let's go to the final one. Is this one here, is this file here, is this picture here that is showing the whole robot just before they're using the joints in RViz in the notebook. Okay, so just before that here. So the cell code that you have to copy is all this. So select all of them, all of it. Then let's go up, up, up. Okay, and we copy. Let me check if I have selected everything. Yes. So I copy everything, and then I come here to my URDF file, and then I select everything here. You can do it many ways, Control A, for example, and then I delete it, and then I paste the new code. Okay, so, and then I save. Okay, saved. Great. So now let's see if we can get the final version of the robot. So Control C to close the RViz visualization, and I'm going to put it here. Actually, we can do something here, is to detach this window and create a new tab that contains this content here. It's very useful, especially if you have several monitors. You can use this for putting the graphical tools in a different monitor and then have everything at the same time. By clicking this icon here, you can detach any of the windows here and put it into another tab. So let's click here. So now it's opening a new tab here and connecting. Hopefully this is going to work because it has been working. And the previous one has been deleted, okay? So here it is. Okay, no, we have again the same problem. That's very strange. Okay, so yeah, that was a bad idea. So let me come back here and do the graphical tools. And still it's losing its way for some reason. Come on. Come on. Let me see. Let me try again. Okay, so I think that I need to have more code, but I was about to go to the final part and then wanted to show you this very nice feature that it's about detaching this part from there, but it looks like I'm not, it's not working for some reason. So let me save the project again. Let me save it because I don't want to lose my changes. So I have saved everything, and yeah, I need to relaunch it or something. I don't know. I'm going to relaunch now. Open project. And let's see if that opens. Then Riel, if there is any question there, Riel says fixed. I don't know what do you mean by fix. Oh, the right wing is off. Oh, okay, okay. So I didn't understand your previous comment. Okay, so let's close that. And let's see. Still here. Any other question? Any question, people there? And let's see if this is opening properly. I think I need some more coffee. And here we have, you see, whenever I mention the coffee, that's the solution, yes. So let's go to the graphical tools. I want to open the graphical tools. Okay, so I want to detach here to another window. And there it is. So I don't understand this here. Okay, I promise that we'll analyze this problem and figure out what's happening and not happening that again. So that was, then I need to launch. The final thing is to launch. So let me open another shell and launch my command. Remember that I have here the window where RViz is going to appear. So that's a graphical tool. So let's launch narrow description, URDF, visualize, and there it is. Okay, then let's come here, and here we have everything here, and the robot, that is the model of the robot that is visualized there completely. Okay, so there it is, we have it. So now there is something else here that is this joint state publisher here that you can see here. As you can see here, we have RViz, that is what we are watching here. And also we have the joint state publisher. Okay, so the joint state publisher, if you click here, has been activated. Remember that we included this into the launch file. So we have it here. And what it does provides, the joint state publisher, it provides us some slides that we can use to test the different joints and see if they are moving properly. So if you select any of the joints and then you try to move, you should check that it's moving between the values that you have specified or that you know. So you can see here I'm moving one of the first joints properly, then the other one. So you should test all of them and see all the ones that are joints and see if they are working. Actually, there is a randomize here that is quite useful because it's going to move all of them. But then you cannot see the limits, okay? So these ones here, for example, are the ones of these parts that use as guidance in the fish. One here, yeah. And let me click back into the robot state publisher. And if I change it, so they are going to move on the slide. Okay, so basically that's it. That's the whole content of the notebook. It was, remember, it was about how to build your robot URDF, but while building, check that it is working and you have not created any problem. And let me provide you with some homework, okay? So in case that you like it this and you would like to improve or do something else, your homework, should you choose to accept it, is to add transmissions and controllers to the joints. So you can move the joints from a ROS program, sending joint values to a topic. Okay, so at present, we are moving the robot by using this slide here. It's just publishing directly with the joint state publisher. Okay, but there are no controllers there. We are not providing any ROS controller here that allow us to move directly, sending values. So we need to have those controllers. For that, you need to add the controllers, the ROS controllers, and yeah, so that will need the transmissions also. So if you don't know how to do it, I have included here the ROS control introduction live class that we did some months ago, and that's going to help you. Then finally, before finishing, let me tell you that if you like this kind of method of learning that we have been doing here about doing some notebook with instructions and then doing the practice at the same time using the simulations in your own computer without having to install anything. So I want to recommend you an online academy that is called the Robot Ignite Academy. And there we have developed this method that we call the 30-70 method. Why we call like that? Because it's called the 30% of the time in learning the theory, but most of the time, 70% of it is by practicing with the simulated robot, as you have done here today. I have included here some links for the Academy, but especially some of the courses that we have that maybe you may be interested because they are very popular, like OpenAI for ROS. And then if you click here, you are going to get the course and get the content, the robots that you are going to use, etc. So have a look at that. And let me see. But now let me close here the desktop sharing and see if there is any question from your side. Okay, I'm here for your questions now. We have some minutes yet. So let me see. Rahmit says, why there is a gap in between all the links? Oh yeah, that's just because of visual things. I think that the real model of the robot, the narrow robot, it's actually the model of a real fish robot that has been created in Zurich. And I think that they have those gaps in the middle because they have some controllers, the motors there. So that's why they have the gap in there. But I'm not sure. In any case, if you don't like it, you can try to put them by changing the actual URDF. You can change it and then make them close. The thing is that if you make them close, then when they move, they will not have space enough without colliding one part to another. So that's probably why it has that gap there. Then Real Joseph says, coffee is the solution. Yes, coffee is always the solution. Yes, Real, you got it. Yes. And then Rahmit says, is this possible to add camera on leader for obstacle avoidance application? Yes, definitely, yes. You have to include that into the URDF. And also you will need to include some plugins for the simulation, so you can simulate this. Remember that what we have seen there is not a simulation, is the RViz, is a visualization tool. Okay, so this thing cannot react in front of obstacles or things like that. So you need to create actual gazebo simulation. And for that, you need a URDF. Okay, so you have a big part already done, but you need to include some more things like the, as I mentioned, the transmission, the controllers, also the collision parts, and yeah, and then launch it inside a gazebo simulation environment. You need that. And then if you do that, then you can add the leader and the camera and include the plugins for those. So the robot fish will be doing the moving around. You can create some controller for moving the robot like this, and then it will move around and send you the data through a ROS topic, the data from the laser and from the camera. Okay, then Andrew says, awesome. Now that we have built a virtual robot using URDF, we go about bridging the gap to reality? I guess I'm asking about making a subscriber that then write to GPO and Raspberry Pi, for example. Yeah, so if you want to build that in reality, then you have to start building. Then you can use those, remember the die files, the Collada files, you can actually use that to print in 3D the actual parts of the robot. So you can do it. If you want to learn more about that, you can use Blender, for example, and you can import those die files and modify, add some maybe some holes to put some sensors or whatever. But the thing is that you can print that and then add, of course, Arduino for controlling the motors, and then Raspberry Pi to control the whole system in ROS. That's possible. A lot of work there, but we have some videos in our YouTube channel that show how to use Arduino and Raspberry Pi to build an actual real robot. Check our channel, please, because we are publishing a lot of information about ROS every day there, and in different subjects, in simulations, in real robots, and for ROS2, for many subjects. So have a look at there. And then Jim says, how do I save my workspace if I want to come back later and add ROS control? Yeah, very good question. I shown you before when I had some trouble, but let me show you right now. So it's very simple, actually. There is an icon that is representing the saving. You know this icon here? Then save your project. So you click here, and then it's going to show you this and say, hey, do you want to save with this name? You can change the name if you want to create a copy, for example, and then you click save. Then say, hey, wait, it's going to be overwritten, the one that you had initially. Yes, okay, yes, I want to overwrite my project, then saved. We are working now at present with a system that is automatically saving, so you will not have to use this button. It's going to be released along this week or next week. So in a couple of weeks, you will not have to even save. Everything will be saved automatically, but still not. So do it if you don't want to lose your work, okay? Then Jim says, I think I figured out, okay. Daniel Alfonso says, where can I get the links meshes files in order to work in my ROS version? Yeah, it is included there in the ROS yet. Remember, I put it there on the home user. So on the home user, you will see that there is a meshes.tar file, and then you can right click and then select download to get the files into your computer. Remember that everything that you have created here, you can download to your local machines. That is not a very good idea because, I mean, it's a lot easier to work there on the cloud, but if you want to download, you will get all the files on your local machine. Okay, then Palav says, can I span 2 robots at once in RViz? If yes, how? Yes, you can. You can do that. Yes, how? It's a little bit difficult. Okay, so what is the purpose first? So what is the purpose? So I think that you are confusing. Why I'm asking you this? Because I think that you are confusing RViz with a simulator. So in Gazebo Simulator, you can launch as many robots as you want, and your CPU is able to handle, okay? Because the more robots, the more CPU is going to take. But in RViz, you can do it, but you have to link them to all the models that you launch have to be linked in some way to a specific central frame. That could be the wall frame, let's say. But so all of them, they have to be linked there. But you can do it, of course. And then what else? What would be the differentiating parameters between the two models? No, you don't have to, the parameters are the same. What you have to change is it's a ROS param that is called the robot description. So if you go here, let me share again my screen. Let me share, because those are very good questions. I don't have time for asking more questions, but I can see that very, very good questions. So let me take some extra time. Then here on RViz, let me close the joint test. Well, not close, but minimize. Then here, you can see here, you have robot model, okay? Then if you click here, then you can, here where it says robot description, here is the name of the parameter in the ROS param server where you have loaded this data about the robot. So what you can do is to come here to the code. Let me open the code. And remember that in the launch file, we have loaded the URDF into, let me see what's here, and URDF, no, narrow complete, here. So here, let me show you. Here, this is the robot description parameter. You can see, you see? So this robot description parameter, this is the param name, yes? And this is exactly the param name that we have here. You see? Then you could, for example, add another one by adding another one, another robot model. Let me see. Another robot model. And then now, in this case, we change this by a robot description number 2, let's say. Robot description number 2, okay? So in robot description number 2 at present, there is nothing because nobody has loaded anything in there. That's why it says error, error. There is nothing there. Okay, so what we can do is, for example, is to add another one, another line here, like this one. So you can copy this line, Control-C, and then put it beneath that one and say that is going to show here a 2, for example. So you are going to load again the URDF into the robot description number 2. Okay, so let's save it and let's kill this process and launch it again. So now if I go here, then I have the robot model. So sorry, I have to add it again because I kill it. So here, the robot model again. And then we have to indicate here the robot description too. Okay. Okay, so now you can see that there are 2 fishes there. Yes, I know. I know you can only see one. Yes, I understand. It's because what I mentioned, that you need to put them into different TF locations in order to see them. So how can I demonstrate you that there are 2 different ones? Okay. The problem is that both of them, they have the same shape. So there is one on top of the other. So you only can see one. But then what we can do is to close this visualizations, and then if I activate the second one, you see that there is another fish there. Okay, so if I activate the first one, then I have 1, and if I activate the 2, then I have 2 robots there. Okay, but in order to separate them, you have to publish in different TF the base link of one of the other. That's what I mentioned about you need a common wall frame, where to link them. Okay, so let me see if I can quickly answer all the other questions. Let me see, here again. So here, too many things. How can we compute simulate the motor torque while we move the robot? Probably somehow in Gazebo. Yeah, so you have some parameters in Gazebo to configure that. It's already done there in the Gazebo. So there are many parameters there that it depends. Well, actually it depends on the configuration parameters of your controller. So have a look at the ROS controllers. I think that there you can, you can specify the torque of the motors. Yeah, definitely, yes. You can specify there, but that will be applied only to the for the Gazebo simulation, okay? For the Gazebo simulation. Have a look there. Then I was following Morpheus share. That's Andrew that says, I guess I missed the episode that show it. I have plenty of Arduino project, but I want to move them to ROS. Yeah, so that's what I mean. The Morpheus share series of videos that we are doing, we are using Arduino a lot for many projects. So we saw, we haven't built one for this fish robot, but for a wheel robot, and also for a pan and tilt robot. And then Miguel, who is creating those videos, he is showing how to do that, how to use Arduino, how to use Raspberry Pi for those projects. So have a look there. And then Marcus says, sorry, Gazebo. Yes, so Marcus, I was answering you about the motor torque. It's there, it's for Gazebo, in the configuration of the controllers. Then Andrew says, I'm just confused with how we go from ROS topics to pins. Okay, yes, so that is, okay. So if I understand what you mean by pins, I mean, I think that you mean the actual electronic connection pin that controls the motors, for example. So how do you do that? Okay, you have the motor, then you put an Arduino that is controlling this, and then you use a Raspberry Pi here with ROS on top that is connecting through ROS serial. It's connecting through ROS serial with the Arduino and is sending the commands to ROS serial, through ROS serial to the Arduino. And Arduino is the one that is providing the commands to the motor. And the Raspberry is the one that has the topics because it has ROS on top. Arduino doesn't have ROS on top. Then you need the Raspberry or another computer that uses ROS serial to communicate with the Arduino, and then the Arduino communicates with the motor. So that's basically the sequence. Have a look at the project that we have put there. Really, that's explained there. Or better, let me show you. So we have a specific course online that shows even the parts that you have to build, to buy, and where to buy all the different parts in order to build your own robot from zero, from scratch, and ROSify it. So you can send commands to the wheels, you can capture data from the camera. It's called ROSifying a robot, and let me show you where it is, because you are showing so much interest. So let me show you. It is here. If you go to this icon, you are going to get access directly to the Academy. It's here. And then we have a course here. You go to courses, and then it's ROSifying a robot, building and ROSifying a robot from scratch. And then in this course, you're going to learn how to build this robot here. And we provide all the details, all the how to buy all the parts there, how to connect them, and how to make them ROS. Also, you are going to learn how to build a simulation for your robot from zero. Okay, so how you create the motor drivers, how to connect through Ethernet or Wi-Fi to the physical robot. And also, at the end, we are showing how to use autonomous navigation with line following with that robot that you have built, how to do monocular navigation, and even apply deep learning to your robot. So have a look at this course there, and let me know if that mostly saved the day. Okay, so I think that we have to finish here. Sorry, guys, I don't know if I have missed the question of somebody. And then, but I have to, yeah, so I don't have more time. It's been a pleasure to talk to you, and you have so many questions. So if you have more questions, or I didn't answer all of your questions, please put it beneath this video. Write them down beneath, and I will answer them for sure. Maybe it's not going to be now, but tomorrow, okay? And of course, please give us a like, thumbs up in our video if you like it, okay? And if you didn't like it, then tell us why. Tell us why on the comments of the video beneath, okay? So, and also, of course, subscribe to our channel. It is free, and you are going to get a lot of knowledge, guys. So thank you very much, everyone. Thank you for being there and practicing. It's my pleasure to teach you, and see you next week on a new live class that is going to be about Linux for robotics. So we are going to learn the basics of Linux, and because many people that approaches ROS doesn't know about Linux, so we are going to teach about this basic. It's going to be very basic course, teaching you how to use Linux, but apply to robotics, to the robotics subject that we love so much. See you guys. Remember to keep pushing your ROS learning, okay? And always the coffee. Yes. Yes, my coffee. Yes, I needed that. Yes. Okay, finish. Yeah. Very good. Yeah, so long time. Yeah. Yeah. So many questions. Yes, but thanks that I have my coffee, and it's I forgot to close the camera.